Hello folks, in this video I want to show you something rather cool that I've been working on. Well, it's complete now, so that I've worked on. What I've done is created a, what is it called? Perceptron, which is basically like a singular unit from a neural network. So we can distinguish between two different things as opposed to a network which could distinguish between a whole bunch of different things or give you a whole bunch of different outputs. So I've taken that and I've used a genetic algorithm to evolve the weights and biases for it so that it will be able to evolve itself to do something. In this case, I have it distinguishing between two types of clouds, cumulus and cirrus. So yeah, I just wanted to show this application off. It's nothing super duper fancy if you know how to do genetic algorithms and what was the other thing, the Perceptron, neither of which are really hard. You just need to know how to program. So anyway, so this is the data set that it works with. I'll leave the zip file for this project in the description. So if you want to download it, you can open it up and try out your own data set. You would have to change a few different things in program.cs. So you would want to have a look through the project first. But anyway, so here's the data set. You can see we've got a description here. So it defines two types of cloud, cumulus and cirrus. Cumulus clouds are between 2,000 and 7,000 feet in altitude and are puffy in shape. That's represented by a 0. So 0 is puffy in shape. And then cirrus clouds form anywhere from 16,500 to 4,500 feet in altitude, or 45,000 feet in altitude, and are thin in shape, which is represented by a 1. So here we have the training data that the program will actually take in and train itself on. So you've got the altitude first, and then the shape. So 0 is puffy, and then, excuse me, thin is 1. And then right here you have the type of cloud. So 0 represents, cumulus, and 1 represents cirrus. So we've got 10 examples, 5 cumulus, 5 cirrus clouds, and then we have some test data. And you can distinguish the test data because number 1, they only have the altitude and the shape. They do not have what type of cloud it is on the end. And then number 2, it's got this little question mark. So I'm going to go ahead and run the program. And it'll just load up the data set after we press enter and then evolve itself and then run the test data. So I'm going to go ahead and run. So it loaded up the, name and then the description. And then it took 24 generations to fully evolve. And the fitness 10 basically just means it was able to correctly identify all 10 pieces of data in the data set because that's what it tests itself on, sorry. So it got to maximum fitness, which means it was ready to actually process the test data. So I forgot to mention the test data. So this is a cumulus cloud because it's in the appropriate altitude range and also has the right shape. And this is a cirrus cloud, same deal, appropriate altitude and shape for that cloud. So as you can see here, this line right here is saying that the first bit of data is a cumulus cloud, which is correct. And this one right here is a cirrus cloud, which is also correct. Now, just to demonstrate the functionality of this, I can go ahead and add on another piece of data for it to train itself on. Oh yeah, the other thing I forgot to say, these two pieces of data are not in this data set. So the the Perceptron has never seen these data sets before. So let's add another one. Excuse me, so I'm going to flip a coin. Tails will be cumulus and heads will be cirrus. So it's heads, we'll do cirrus. So I just have two things here. So I'll generate a random altitude for it right here. So I'll copy that, paste it in, excuse me. And then it's going to be thin in shape. So let's go ahead and run this. Press enter. And that time it took a little bit longer, 365 generations, which happens to be the number of days in a year. So that's funny. Anyway, as you can see, a new line has been added. It says a cloud that's thin in shape and has an altitude of however many it was, like, 40,000. About feet altitude is a cirrus cloud, which is correct. So let's add one extra. Let's do a cumulus cloud. So that is this many feet in altitude and is puffy in shape. So that is a 0. Save that and run it. And 181. So it actually it got it slightly wrong. So it got all of them correct except this one, which is not surprising. It can occasionally mess up. It guessed the first data, or it identified the second piece of data as a cumulus when it's actually a cirrus. I'll run that again and see if we get the correct result sometimes, or if we get the correct results. There we go. So cumulus, cirrus, and cumulus again. So that's correct. So yeah, it can mess up occasionally due to just how the genetic algorithm works, but it's pretty minor. So I'm going to delete that just because I want to leave the data set as is. And let me just quickly provide proof that I'm not just using an if case to do this. So you can look at all this code if you want to, and again, the project will be in the description if you want to download it and look through the source code. But right here, you can see console.writeLine, a cloud that is cloud shape and has an altitude of cloud altitude is a cloud type cloud. So this is the message that's being printed. Let me just start this up. This, let's see, this message right here is being printed right here. So if you'll notice, cloud type is what is determining what type of cloud the neuron thinks it is, or sorry, the perceptron. And right here at cloud type, it's determining between cumulus and cirrus based on perceptron result, and perceptron result is the value that's returned by the perceptron object's activation function or activate function that takes in the test data, which is a double array. And if I quickly move over to the perceptron object that I made, let me pin this so that I can keep my space. Over here in activate, you'll notice that it just does a check. It computes the weighted sum, it adds in the bias, and then it returns a sigmoid function of the weighted sum, which is literally just it does the sorry, the sigmoid function takes whatever number you give it and performs the sigmoid function on it. So there is no if case, excuse me, that is determining like, oh, it's within this altitude and range, so therefore, or it's this shape and this altitude, so therefore it's this type of cloud. It is actually passing the test data in and having the perceptron think about that data. So anyway, that's pretty much it. If you have any questions, please leave them in the comments. I'll try to answer them if possible. And yeah, next time I should have a actual fully functioning neural network that can be evolved. So that'll be pretty interesting. I could do a lot of things with that, like get it to learn how to play a game or take in some static data. But the difference is I can output more than one result or more than two results because the perceptron can only output basically true or false based on the inputs. But an entire network could give you like, well, anything you want. Anyway. So that's the end of the video. Thank you for watching, and yeah, have a good day.